Hi guys. Today I will introduce some academic papers that tackle fascinating challenges in the field of language models. These papers explore topics such as improving visual reasoning, enhancing logical inference, generating location-aware questions, enabling instructable embodied agents. Each paper offers unique insights and innovative solutions that push the boundaries of language models. Get ready to dive in to the exciting world of cutting-edge research. The paper Large Language Models Are Visual Reasoning. Coordinators introduces a new approach called the COLA paradigm to solve the challenge of coordinating multiple vision language models for visual reasoning tasks. The authors propose using a large language model, LLM, as a coordinator to efficiently integrate the strengths of multiple VLMs. They also present two variants of COLA, COLA FT, which achieves state-of-the-art performance by tuning the instructions, and COLA 0, which performs well in 0 and few shop settings without fine-tuning. This paper is important because it provides a solution to improve the performance of visual reasoning tasks by effectively combining different models. The paper LNC introduces a new approach called logical inference via neurosymbolic computation to improve logical reasoning in large language models. LLMs often struggle with tasks that require reasoning out of domain, understanding negations, and following long reasoning chains. LINC addresses these challenges by using a two-stage process. And first, the LLM translates natural language into logical expressions. And then an external air improver performs deductive inference. The paper compares LINC to 3 baseline strategies and shows that LINC significantly outperforms them in various experimental conditions. The paper also analyzes the errors of LINC and another method called chain of thought, highlighting their distinct failure modes and potential synergy. And overall, LINC offers a promising solution to enhance logical reasoning in LLMs. The paper Location-Aware Visual Question Generation with Lightweight Models introduces a new task called Location-Aware Visual Question Generation. The goal is to generate interesting questions for in-car intelligent assistant systems using GPS coordinates and street view images. The paper proposes a dataset generation pipeline that uses large language models to create diverse and sophisticated questions. It also presents a lightweight model called FDT5, which performs better than other models in terms of human evaluation and automatic evaluation metrics. The paper's contributions include the introduction of the LOCA VQG task, the dataset generation pipeline, and the FDT5 model. This research is important because it helps improve the capabilities of intelligent assistant systems in cars. The paper Open-Ended Instructable Embodied Agents with Memory-Augmented Large Language Models introduces a new approach to help robots understand and follow human instructions. The authors have created an embodied agent called Helper, which uses a special type of computer program called a large language model to understand and execute instructions. Helper also has a memory system that allows it to remember past instructions and use them to improve its performance. And this research is important because it helps us develop robots that can understand and interact with humans more effectively, making them more useful in our daily lives. The paper LLM-in-the-loop introduces a new approach to qualitative research called thematic analysis. It aims to solve the problem of TA being time-consuming and labor-intensive. The paper proposes a collaboration framework between humans and large language models to make the process more efficient. And the key idea is to use in-context learning to design prompts for data analysis. The paper suggests using a machine coder or followed the different machine coder to extract initial codes based on the research question and free text responses. These codes are then refined through discussions between the MC and a human coder, HC. The final code book is generated by identifying themes with the help of both the MC and HC. The paper also addresses the limitations of LLM input size by using partial data for codebook development. Overall, the paper's contribution lies in providing a solution for using LLMs to analyze long text qualitative data, making the process faster and more effective. And the paper, Plan, Verify, and Switch introduces a new way to help large language models, well, LLMs, solve math problems. These models are very smart, but they struggle with math reasoning tasks. The paper proposes a framework called XOT that combines different methods of reasoning to improve the LLM's performance. ZOT has 3 modules: planning, reasoning, and verification. The planning module chooses the best method to use. The reasoning module solves the problem. And the verification module checks if the solution is correct. That ZOT has been tested on different math problems and has shown consistent improvement. This framework can also be used for other logical reasoning tasks. And I think you can pair them and tell you, using models, did everything kind of like special credit card to do so that makes sense to mean for turn to get there, get the CAMBIs. The CAMBIs, the paper proposes 2 collaboration methods: CRS assisting LLM and LLM assisting CRS. By analyzing the impact of these collaborations on different tasks, such as understanding user needs and generating recommendations, the paper finds that the collaborations can be effective in certain cases. This research is important because it helps us understand how to enhance the effectiveness of e-commerce pre-sales dialogues, ultimately improving the shopping experience for customers. The paper CoF-CoT introduces a new approach called course-defined chain of thought to help large language models better understand and process natural language in dialogue systems. The authors break down the tasks into smaller steps, allowing the LLMs to acquire and use concepts from different levels of detail. They also integrate a structured knowledge representation called abstract meaning representation, AMR, to capture the nuances and connections between different levels of granularity. The paper demonstrates that this approach is effective in helping LLMs adapt to different NLU tasks in multi-domain settings. Overall, the paper contributes to improving the capabilities of dialogue systems in understanding and responding to human language. The paper, that Generative Pre-trained Transformer for Vietnamese community-based COVID-19 question answering, focuses on using a special type of artificial intelligence called Generative Pre-trained Transformer. The authors wanted to find the best way to use GPT to answer questions from the Vietnamese community about COVID-19. They compared different models and found that GPT-2 was the most effective. They also created a new data set of COVID-19 questions in Vietnamese. This research is important because it helps people in the Vietnamese community get accurate information about COVID-19. The paper Retrieval-Augmented Chain of Thought and Semi-Structured Domains addresses the challenges of using question answering systems in specialized fields like law and finance. These domains often involve long and complex information that exceeds the capacity of existing language models. And the paper proposes a solution by leveraging the structure of legal and financial data to efficiently retrieve relevant context. It also introduces a step-by-step approach called chain of thought prompting to generate answers. The paper outperforms existing models in these domains and provides useful explanations for the answers. It encourages the integration of large language models into legal and financial NLP systems for future research. The paper Monte Carlo Thought Search introduces a new approach called the Monte Carlo Reasoner, MCR, to help scientists design catalysts. Catalyst design is a complex task that involves considering many different chemical properties and trade-offs. The MCR uses a method called Monte Carlo Tree Search to prompt large language models, LLMs, for answers to difficult questions in catalyst design. The paper also presents 2 new data sets that contain simulations and questions from catalysis researchers. By using a reward function based on adsorption energies, the MCR improves the quality and specificity of the answers provided by the LLMs. This paper is important because it helps scientists make better decisions in catalyst design, which can have a big impact on many industries. And then the paper, the large language models and multimodal retrieval for visual word sense disambiguation, explores a problem called visual word sense disambiguation, VWSD. This problem involves finding the right image that represents the meaning of a word in a given context. The paper suggests using large language models as the knowledge bases to help understand phrases and resolve ambiguity in VWSD. It also proposes converting VWSD into a simpler problem by using text-to-text and image-to-image retrieval, as well as question answering. The paper's main contribution is training a model that combines different modules to achieve better ranking results. This research is important because it helps improve our understanding of language and how it relates to visual information. The paper on bilingual lexicon induction with large language models explores how to create bilingual dictionaries for different languages using large language models. These dictionaries help computers understand and translate words between languages. The paper suggests different methods for training LLMs to perform this task, such as using example translations or fine-tuning the models. The authors conducted experiments to test the effectiveness of these methods and found that LLMs can successfully bridge the gap between languages. And so this research is important because it improves multilingual natural language processing, and then helps people communicate across different languages. And the paper AutoDAN introduces a new method called interpretable adversarial attack on large language models, LLMs. It aims to address the vulnerability of LLMs to jailbreak attacks, which can compromise their safety alignment and lead to the generation of harmful or inappropriate content. AutoDAN generates attack prompts from scratch using optimization, allowing them to bypass filters while maintaining a high success rate. The paper also shows that AutoDAN generated prompts exhibit strategies commonly used in manual jailbreak attacks and transfer well to black box models. This research is significant as it highlights the need for improved security measures for LLMs to prevent the generation of harmful content. The paper branch solve merge improves large language model evaluation and generation, introduces a new approach called BSM to enhance the capabilities of large language models, LLMs. LLMs are powerful language models, but struggle with complex tasks like generating coherent stories and evaluating responses against multiple criteria. BSM solves this problem by breaking down the task into smaller subtasks, solving them independently, and then merging the solutions to generate an overall solution. This approach improves the correctness and consistency of LLM evaluation and enhances the coherence of constrained text generation. And overall, BSM is a significant contribution that improves the performance of LLMs and various language tasks. So the paper causal inference using LLM data discovery is about finding out how things are connected and what causes what using a special kind of computer program called a language model. And then the problem the paper tries to solve is how to figure out these connections just by looking at data without doing any experiments. So the paper shows that we don't need to know everything about the connections between things, but just the order in which they happen. The paper also introduces new ways to ask the computer program for this information and how to combine it with other methods to get better results. And this is important because it helps us understand how things work and make better decisions. Okay, that's all for today. We covered a wide range of topics in today's session, including the use of large language models as coordinators for visual reasoning tasks, improving logical reasoning in LLMs. These papers highlight the potential of large language models in various domains and provide innovative solutions to improve their performance and applications. Okay, that's all for today. If you enjoyed my video, I'd appreciate if you could give it a thumbs up and subscribe to my channel. Your support helps me create more content. Thank you. See you tomorrow.